Hi everyone, welcome to the lesson for November 1st. We're going to be covering the content in OMHS. You can find these notes in Unit 3, Day 3 folder. It'll be the first thing posted there. You'll also see the key to this and of course the video. That's how you got to this recording. There's also your exit ticket there and some practice problems. If you haven't been doing the practice problems, I highly recommend them, especially if you feel that you are struggling or you just need just a little extra help. Sometimes those practice problems can at least give you a place to start and a place to start asking questions. All right, so last class we talked about angle relationships. We talked about corresponding angles, alternate interior angles, alternate exterior angles. We talked about consecutive interior angles, and we even talked about vertical angles and linear pairs. And then we used what we knew about those relationships to determine if the angles we were looking at in the picture were congruent or supplementary. And we knew that they were congruent or supplementary because the lines were parallel. Well, today we are going to use the converse of that. Remember the converse from Unit 2? Well, here it is for these definitions. Okay, so last class we said that if two lines were parallel, then our corresponding angles were congruent. Today we are going to use the converse of that and say that if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So last class we said if they're parallel, then corresponding angles are congruent. Today we're going to say the converse is true. If the corresponding angles are congruent, then the lines will be parallel. Okay. So in my example here, I have two lines, line L and line M. They're cut by a transversal and they're forming these 8 angles. So we could say that if, we'll pick a pair of corresponding angles. How about angle 1 and angle 5? If angle 1 is congruent to angle 5, then line L will be parallel to line M. We're going to use the alternate interior angles converse. So last class we said if the lines were parallel, then our alternate interior angles were congruent. Today, we're going to say that if alternate interior angles are congruent, then the lines are parallel. So we'll say if, well, we're going to pick a pair of alternate interior angles, how about 4 and 6. So if angle 4 is congruent to angle 6, then we would know that L is parallel to M. Same idea for alternate exterior angles. So if, let's say angle 2 and angle 8, if angle 2 is congruent to angle 8, then the lines are parallel. And then the big one, this one right here, you got to be very careful. Consecutive interior angles, they're not congruent, they're supplementary. Keep that in mind. I've had some people emailing me asking me why their questions are wrong or their answer is wrong. And I think it's just because they didn't look at the picture to decide what the angle relationship actually was. So just be very careful with your consecutive interior angles. They are not congruent, they're supplementary. And if they are supplementary, then those lines would be parallel. So we'll say if the measure of angle 3 plus the measure of angle 6 equals 180, then L is parallel to M. This one is different than the first 3, so just watch out for it. All right, so let's practice. All right, so the first one says angle 2 is congruent to angle 4. We're going to use that information to determine which lines, if any, are parallel, which means it's possible that they're not even proving the lines are parallel. And if they are, then we'll just say the converse that justifies our answer. So here's what we're going to do. Look at angle 2. Here it is. Highlight the lines that form angle 2. So highlighter. So angle 2 is formed by line C and line A. Then look at line or angle 4. Angle 4 is over here. it is formed by line A and line D. So what that's showing me here in the picture is we don't even need anything down here right now. Like, this is irrelevant. We're just looking at this part of the picture. Which lines would be parallel if 2 is congruent to 4? Well, the two lines that I have highlighted parallel are C and D. And why would they be parallel? So then you ask yourself, well, what is the angle relationship between angle 2 and 4? These are corresponding angles. And when I'm proving the lines are parallel, we're using the converse. So this will be corresponding angles converse. I think it's actually called like the corresponding angles theorem. So if you see that in a word bank, it's the same thing. All right, let's try another one. It says angle 5 is congruent to angle 10. Okay, well, angle 5 is here and 10 is here. Angle 5 is made up of line A and line C. Angle 10 is made up of line C and line B. So line D is irrelevant to this one right now. So which two lines do you think will be parallel? Well, A will be parallel to B. Those are the two parallel lines that we highlighted. And then what is the angle relationship between angle 5 and angle 10? Well, angle 5 and angle 10 are alternate interior angles. Because we're using that to prove the lines are parallel, we're using the converse. So this is alternate interior angles converse. Okay, angle 6 and angle 10, this time it says that when we add them together, we're going to get 180. So let's find angle 6 and angle 10. Here's angle 6, here's angle 10. Highlight the lines that make them. 6 is made up of A and C, and 10 is made up of B and C. So that should show you the lines that are parallel. That'll be A and B. And 6 and 10, their angle relationship, well, they are consecutive interior angles. So we can say consecutive interior, or if you want to say same side interior, that's okay too. Converse. All right, number 1 and angle 1 and 14. Well, here's angle 1 and here's angle 14. Angle 1 is made up of line A and line C, and angle 14 is made up of line B and line C. So the two lines that would be parallel would be A and B. Those are the two that I highlighted that look parallel. And what is the relationship between angle 1 and 14? Well, they're alternate exterior angles. So this would be an alternate exterior angles converse because I'm proving lines parallel. 14 and 15. Okay. Here's angle 14, here's angle 15. 14 is made up of line B and C, and angle 15 is line B and line D. So which two lines do you think would be parallel here? If you said line C and line D, you are correct. The relationship between angle 14 and 15, those are consecutive interior angles again. Hopefully we're getting good at identifying those relationships. Because I'm proving the lines parallel, I'm using a converse. All right, let's look at 11 and 16. Here's angle 11 and here's angle 16. Angle 11 is made up of line B and line D, and 16 is made up of line B and line D. Interesting. I only had to use two lines here. what is the angle relationship between angle 11 and angle 16? They're actually vertical angles. Vertical angles are always congruent no matter what. They're not going to prove the lines are parallel. So this is the first time that we have a none. Okay, so even though that is true, 11 is congruent to 16, it's not proving any lines parallel. Okay, so I'm just going to put a dash here. If you want to put vertical angles, you can, but vertical angles do not prove lines parallel. Okay, and that's what we're trying to do. We're trying to prove that lines are parallel. Okay, how about angle 4 and 15? Angle 4 is here and 15 is here. 4 is made up of line A and line D. 15 is made up of line B and line D. There we go, we're back at business again. Which two lines do you think are parallel according to this information? You said line A is parallel to line B. You are correct. 4 and 15's angle relationship, these guys are alternate exterior angles. That pen just got weird. Hold on one second. There we go. Alternate exterior angles converse. How about 10 and 12? Here's angle 10, here's angle 12. Angle 10 is made up of line B and line C. 12 is made up of line B and line D. So we can see that line C and D would be the parallel lines. And then you ask yourself, what is the relationship between angle 10 and 12? Those are corresponding angles, and we're using that to prove the lines are parallel. This is corresponding angles converse. Look at angle 9 and 13. Here's angle 9 and 13. They are both made up of line B and line C. They're not proving lines parallel at all. In fact, 9 and 13, they're a linear pair. And even though this is true, even though angle 9 plus angle 13 is 180, that is perfectly fine. It's just not proving lines parallel. There's only two lines highlighted there. So this is none. And if you wanted to write a linear pair, you could. Maybe you would write linear pair doesn't prove lines parallel. That would be okay. Angle 2 and angle 7. Angle 2 is here and 7 is here. Angle 2 is made up of line A and line C. Angle 7 is made up of line A and line D. So we can see that the two lines that would be parallel for this piece of information would be line C and D. And the relationship between those two, well, they're alternate interior angles. So we would say alternate interior angles converse. All right, last one, angle 6 and 11. Angle 6 is here and 11 is here. Well, angle 6 is made up of line A and line C, and angle 11 is made up of line B and line D. Uh-oh, I just highlighted all of the lines. Well, that's a problem, right? Because now I can't tell which ones are parallel because this piece of information doesn't prove any of these lines are parallel. There's no relationship between 6 and 11. They're not touching the same transversal. So this is a none, right? So when the three that I had for a none, we had vertical angles, we had a linear pair, and we had a no relationship. If you get those, they're not going to be proving anything's parallel. All right, the next one I would like you to try. Okay, very similar process, just different picture. Look at the angles they give you and see if you can determine which lines are parallel based on that piece of information. And if it's a none, then you just write none. Go ahead and try that now. All right, you can check your answers with what I have on the board here. How'd you do? Did you do all right? Does this feel easy? I hope so. If not, jot down a question or two. I don't understand how you got this answer, Mrs. Grandy. Can you go over it in office hours? And I'll be happy to go over any additional practice problems or answer any of your questions in office hours, or I can do my best to do it through email too. So one of the biggest questions that students ask me is, Mrs. Grandy, when do you know to use just the theorem, or when do you use the converse? You're going to use just the theorem when you're proving a relationship about angles. You're going to use the converse when you're proving a relationship among lines. Let me say that one more time. Okay, so if you are given that lines are parallel, and you are asked to prove an angle relationship. So for example, if I tell you that line A is parallel to line B, and you're going to prove that angle 1 is congruent to angle 2, then this is just the theorem or the rule. You're going to use the converse if you are given information about the angles and you're asked to prove that the lines are parallel. So for example, if they say that angle 1 is congruent to angle 2 and you're asked to prove that lines are parallel, that is when you would use the converse. Okay. So when do I use the converse? When I'm trying to prove lines parallel. So in this example right here, notice that the prove says prove that J is parallel to K. As soon as I see that, my brain says, hey, you're going to use a converse, Miss Grandy. Okay, I don't know converse of what yet, but I know it's going to be a converse. The given information says that angle 4 and 5 are supplementary. So of course we know that this is given. Then what does supplementary mean? Remember, whenever you see a vocabulary word and you're given, you're going to use its definition. Supplementary means you add them together, you get 180. That's exactly what it says in step 2. Angle 4 and angle 5, add them together, you get 180. That's going to be your definition of supplementary. All right. Well, if they are supplementary, so if angle 4 and angle 5 are supplementary, what can you tell me about line J and line K? Well, they're parallel. Why? Well, what's the angle relationship between 4 and 5? They're consecutive interior angles. So I'm going to write consecutive interior angles, converse. Easy as that. Let's look at another example. It says that angle 1 and angle 2 form a linear pair. It also says that angle 1 and angle 4 are supplementary. And we want to prove that line A is parallel to line B. As soon as I see that I'm trying to prove that these lines are parallel, I'm going to be using a converse. So step 1 says angle 1 and angle 2 form a linear pair. Well, we know that's given. Right there it is. The other given says angle 1 and angle 4 are supplementary. I'm just going to find that. Oh, that was step 3. All right, the givens are now taken care of. What does it mean to be a linear pair? Okay. Well, a linear pair are two angles that form a line, which means they're adjacent and they're supplementary. The definition of a linear pair are two angles that are adjacent and supplementary, which is exactly what it's saying here in step 2. Angle 1 and angle 2 are supplementary. That's going to be our definition of a linear pair. There's also another thing that we could write, definition of linear pair. You may also see this called the supplement theorem. It's the same thing. Okay. So the supplement theorem says if they're a linear pair, then they're supplementary. Okay. I like definition of linear pair. When I make these things, that's what I would put. But supplement theorem means the same thing. All right. So we know that angle 1 and angle 2 are supplementary. We know that angle 1 and angle 4 are supplementary. So then step 4 says angle 2 is congruent to angle 4. What do you think goes in the box? Do you remember when we talked about the congruent complements theorem? Well, there's also a rule called the congruent supplements theorem, and we discussed that in that class Connect. What's going on here is it's saying angle 1 and angle 2 are supplementary. Remember, that means you can add them together to get 180. And angle 1 and angle 4 are supplementary. So you can add those together to get 180. Well, those are equal, and angle 1 is the same as angle 1. So what does that tell you about angle 2 and angle 4? They must be equal or congruent. This is called the congruent supplements theorem. So congruent supplements theorem says that if two angles are supplementary to the same angle, then those angles are congruent. So in this case, angle 2 is supplementary to angle 1. Angle 4 is supplementary to angle 1. They're supplementary to the same angle, so those two angles have to be congruent. All right, well, in the picture, here's angle 2 and angle 4. I just proved that they were congruent. And if angle 2 and angle 4 are congruent, then that means that line A is parallel to line B because, well, what's the angle relationship between angle 2 and 4? They're corresponding. So this would be the corresponding angles converse. Wonderful. So that's how you would see it in a proof. Here's where we could use some algebra for it. And this is going to feel really familiar because all that I've done essentially is changed the directions. We're still finding x, but we're going to find x so that A is parallel to B. Last class, I told you that A was parallel to B and you had to find x. You're doing the same process, just slightly differently. So instead of me telling you that A is parallel to B and us finding x, we're going to find x that would force A to be parallel to B. It's the same thing. Okay. But before we do that, you have an attendance word that you're looking for. Your attendance word today is find, F-I-N-D. Capitalization does not matter. You just have to spell it right. F-I-N-D, find. It's your attendance word. Okay, so let's look at number 1. Number 1 says that this angle up here is 10x minus 23, and this angle down here is 137. Here they are. What kind of angle relationship do you see there? Well, these are alternate interior angles. So we're going to use the converse for the alternate interior angles theorem. Okay, so the alternate interior angles converse says that if these two angles are indeed congruent, then the lines will be parallel. So now we just have to solve for x. Add 23 to both sides and divide by 10. So if x equals 16, then those two angles would be congruent, which would force line A to be parallel to line B. In number 2, 9x plus 11 is here, and 74 is this angle. All those are corresponding angles. So we're going to use the corresponding angles converse, since I'm trying to prove the lines are parallel. And that says that if the angles are congruent, then the lines will be parallel. So when we solve for x, we'll subtract 11 from both sides, divide both sides by 9, and we can say that if x equals 7, then these two angles would be congruent, forcing the lines to be parallel. Okay, and number 3, This angle right here is 96, and this angle is 6x minus 30. What kind of angle relationship do these guys have? If you say consecutive interior angles, you're right. So we're going to use the consecutive interior angles converse. The consecutive interior angles converse says if the consecutive interior angles are supplementary, then the lines will be parallel. Notice this one was different. The angles are not equal. The angles are supplementary. So let's combine our like terms. 96 minus 30 is 66. Subtract 66 from both sides. You get 6x equals 114. And divide by 6, x equals 19. If you're following along in the notes that I posted, I think I may have miswritten the 66 as a 36, but the rest of it is still right. So the answer is still right, x equals 19. So if x equals 19, you can plug that in. It would force these two angles to be supplementary, which would force line A to be parallel to line B. And the last one, well, on this page anyway, 33 is this angle and 7x plus 5 is this angle. What kind of angle relationship do they have? If you said they are alternate exterior angles, you're right. Alternate exterior angles, and we're going to use it to prove the lines parallel, so we're using the converse. Alternate exterior angles converse says if your alternate exterior angles are congruent, then the lines will be parallel. So subtract 5 from both sides and divide by 7. X equals 4. So if x equals 4, that would make these angles congruent, which would force line A to be parallel to line B. All right, there are 4 more practice problems for you here. I'd like you to try them. Try them, and then I'll go over them, but at least try them out. See if you can get the answers. So do number 5, 6, 7, and 8. Do that now. Okay, so for number 5, we had corresponding angles. So we use the corresponding angles converse. I didn't write the word converse on my notes. I think I was just looking at the word converse there. So converse was already included. That's fine. All that I really care about is you know that they were corresponding angles, because once those angles are forced to be congruent, then that's forcing your lines to be parallel. So in number 5, we had corresponding angles, so they have to be congruent. So when you solve, you should get x equals 12. If you did not get x equals 12, go ahead and check to see, did you set it up correctly? Did you say 8x minus 17 equals 5x plus 19? Or did you accidentally make them supplementary? So double check that. If you can't find your error in your algebra, you may always reach out to me. Take a picture of it and send it to me, and I'll happily try to find your error and help you fix that so you don't make the mistake again later. The one that maybe you made a mistake on maybe was on 6. I think sometimes students, they just want them always to be equal, so they just always make them equal, but be very careful. In number 6, the consecutive interior angles are what's labeled. So that converse will tell us that if those angles are supplementary, then the lines would be parallel. So you should have added those two expressions together and set them equal to 180. You should not have made them equal. And if you look at those angles even, one's acute and one's obtuse. You can't have an obtuse angle equal an acute angle. That wouldn't work. So they can't be equal. So your only other option is supplementary. And you should get x equals 13. And number 7, those were alternate interior angles. So the alternate interior angles converse says that if those alternate interior angles are congruent, then the lines will be parallel. So you're going to set them equal to each other. Solve for x, you should get 21. And then number 8 made you remember that that little box right there means 90. So maybe you wrote like a little 90 here. And so now you have some corresponding angles. The corresponding angles have to be congruent to force the lines to be parallel. So if you wrote the word converse on all of these, that would be awesome. If you didn't, Just know that we were using the converse because we were proving the lines parallel. So when you made 4x minus 18 equal 90, you should have gotten x equals 27. Hopefully, these relationships are starting to get easier for you. All right. And the last two that we have in the notes here, we have these two angles labeled. We can do these together. We've got alternate exterior angles. So this will be alternate exterior angles converse. The alternate exterior angles converse says that those two angles must be equal to force the lines to be parallel. So I'm going to subtract 23x from both sides, add a 20 or add a 19 to both sides, and divide both sides by 4. So if x equals 5, then these two angles are congruent, forcing A to be parallel to B. The last one, number 10. How would you set this one up? What do you think? What would your setup look like? Well, these are consecutive interior angles. So we're going to use the consecutive interior angles converse, which says if your consecutive interior angles are supplementary, I'm going to write it up here so I don't have run out of space. Supplementary means that they add to 180, then those lines will be parallel. So your setup should have had the two expressions added together and set them equal to 180. Combine like terms, add 7 to both sides, divide by 17. You should have x equals 11. And if you wanted to check that, you could. You would take that 11 and plug it in. 13 times 11 minus 2, 4 times 11 minus 5, add them together, you better get 180. All right, so that was all today's lesson. Hopefully that felt kind of easy since it really was the last lesson, just backwards and kind of backwards, just using the converse instead of the other way around. There are practice problems on OMHS if you want to practice more of them. And of course, you can always reach out to me with questions and visit me during office hours. Don't forget to do the attendance quiz. Don't forget to do your exit ticket. And I hope you have a lovely day.